Hello, I'm Alex Renz, and today I'll show you how to put a Nios II processor on the Altera DE10-Lite development board. This is for EE492 Advanced Digital Hardware Design with Dr. Fourney. Okay, so starting out, I'll open up Cordis. I already have this open. This is the latest version of Cordis at the time. It's a 16.1.2. This is the screen that shows up when you first open Cordis. We'll start out fresh with a new project. This you can just skip, and then for a new project you first choose where to put your project. So I will just make a folder here called Nios II Demo, and this will create the name of the project as well as the top level entity. We'll just create an empty project. You can download project templates from Cordis's website, and this can be for like the development kit. You can have a template that will already have all the pins mapped for you. This is add files. If you're creating a project and you already have some hardware design files, you can put it in here. If you don't have anything, this you can select what board you want. I already copied the board or the FPGA that is on our DE10 kit, so I can just put it in there and select it. And just hit next on here and finish. And now I'll create a project for our Nios II. Alright, so now the project is created. We will go to the QSys icon and click on that. It'll open up the QSys tool, which will allow us to build our Nios II system. Alright, here is the Nios II window. You can add a variety of Cordis IP in here. Today we'll just be doing some basic Nios II and I/O modules. It will start up with the clock automatically. This you need in any design. And you can see the clock. We have exported clock and reset. The clock signal will be coming in. In this case, on our development kit, we have a 50 megahertz clock. And reset, we will use an input from the processor to control that. So you can just search Nios up in this box here, and you can see the Nios II processor down below. We will double click that to add it, and it'll come up with this box. You can choose the Nios II Fast or Economy. We're going to go with the Economy for right now, and just hit finish. Alright, so right now we have the clock and the Nios II started. What we're going to do is next we're going to add memory. We're just going to use the FPGA on-chip memory. It starts out with 4 kilobytes. We'll just increase that to 40K. This will allow us to use a decent amount of features on C++ and have some memory. That's all we need to do at the moment. Alright, and next we'll add a JTAG debugger module, so you can write to console and do other debugging features. You don't need to change anything here, you can just hit finish. And we will also add some parallel I/O. This you could use as switches or LEDs. You can set the width of the bus, we'll just keep it as 8, and you can select input, output, whatever. We'll do output for this one, and then we can rename these. We'll rename this as LEDs as is output. And then while we're doing that rename, I'll also rename our Nios II to Nios II demo to match our top level file name. We'll add another parallel input output, this time as an input. We'll keep it as 8, and we'll rename this to switches. Alright, so now we have all our modules that we'll need for this simple project. We have a clock, Nios II processor, memory, JTAG UART, LEDs, and switches. So now what you do to connect all these modules together, use this connection sidebar here. We'll start with the clock, which comes out here, and we'll go down and we'll connect the clock to every module. Alright, next we have the reset, which comes out of the clock, and we'll connect that to every module again. Alright, so next we have the clock input reset. Like I said before, we'll use the output from the Nios II for that one. So you click on these little, click on here to connect that debug reset request into the clock. And this leaves our clock input, which will come from our dev kit. So now we need to connect our data and instruction to the rest of the modules. For the data, this will go to the memory and to all the other modules, as everything is memory mapped. The instruction only needs to go to the memory, as the instructions are held in memory, but it won't need to go to any of the other modules. Finally, we have this interrupt request, our IRQ, which will go down to the JTAG so it can interrupt the processor. And you can see this also makes a connection on the interrupt request vector column. Alright, so now that we have all our connections made, we can add in these external connections for our parallel I/O. If you just double click, it'll automatically name it whatever this is named an external connection. We can just leave it at that, and that will allow you to connect whatever you need to your parallel I/O, in this case LEDs and switches. So now we will save it. We can just save this as Nios II demo, and we'll save it as a QSys file. Alright, and we will go to System, Assign Base Addresses. This will go through and assign all the memory addresses to all our different modules. You can see that got rid of a lot of warnings. We still have 2 left, which is for the Nios II demo. You need to specify vectors for the reset and the exception. We couldn't do this at the start because we didn't have the memory connected. So now that we have everything connected and those addresses assigned, you can go to the I double-clicked on the Nios II processor, and this will pop up, and you go to the Vectors tab and do the on-chip memory for both of these vectors, and then we're good. All our error messages are gone, everything's green, so we can save this again and close. Alright, now we will generate the hardware design files. Here you can choose Verilog or VHDL, which is Verilog. You can create these timing for the other synthesis tools, but that is not necessary for us. And we'll hit generate, and it'll go through and generate all the needed Verilog files. Alright, all the files have been generated successfully, so we can close out of that, and we can close out of QSys. Alright, this is just warning you that you have created IP in the file, and to add that IP into the project, you go in and add the Nios II demo.qip file. So we'll do that. Go in Files, right click, Add Remove Files in Project, and it showed up. It'll be under here, and Synthesis, and the QIP. So you can apply here, and that will show up. These are all the files in that QIP file that control that. You can open up these files, look at them. This is the top level file for the Nios II. We don't really need to worry about that for this. What we'll do is we'll right click on that file, and it says the top level entity, and then we're good to start analysis and elaboration. We'll do this, and then we will assign the pins. Alright, so we have used the analysis and elaboration button to elaborate our hardware files, and what we'll do next is we'll go to the pin planner and assign our pins to our FPGA. The clock, the 50 megahertz clock is pin P11. I have the user manual up on the PDF, and you can go through, you can see the clocks and all the other I/O in the board, including your switches and LEDs. For right now, I'll just leave the switches and LEDs not assigned. That can be done in a later project, as we're just doing a hello world in this. So you can close out of this. And then there's one more step you need to do specifically for this DE10. I have it up on the sticky note. Before you can do a full compilation, let's go to Assignments, Device and Pin Options, Configuration tab, and this configuration mode needs to have an option with the memory initialization selected. This is because it is flash, and it will not get through the fitter part of the compilation if you don't have that selected. For that option, that's the second thing I had on the sticky note. You can see here if you're following along. Alright, so now we will do a full compilation. Alright, so our design has been fully compiled now, and we can go to the software side of the project. To do that, you go to your tools, and then you're gonna find the Eclipse tools for Nios. It'll ask you to select a workspace, so I'm gonna go to the same place that my demo project is located. Alright, so the Eclipse workspace will open up. We're going to go File, New, Nios II Application BSP from Template. Alright, it's going to ask you for the SOPC information file name. That was generated by our QSys, so we will go to our, wherever that was located. The SOPC info file. It'll load that up. So now that's loaded up, it'll show your CPU name. Mine is Nios II Demo, and it'll ask for a project name. I'll just keep the theme of Nios II Demo going. I'm just using default location. You can specify exactly where you want this project to go. We're going to use hello world small, which cuts out a greater portion of C, so you have less C functionality, but you take up a smaller footprint. We're just going to go finish, or if you hit next, you can see that it's going to create a board support package, or BSP, from this. We're just going to keep everything at default on this side too, and it will go through and create a new project for you. Okay, once the project creation is done, you can see that we have a Nios II demo. This is our C project, and then it also has a Nios II demo _ BSP, which is our board support package project. Here you can open up your hello world small, which holds main.c, or your int main, in here. You can see all this comments they have, and they're just including their system alt standard IO.h. This is a smaller version of the C standard IO.h. All this C file does is it puts hello from Nios II up on the console and then loops forever. This version of the C has logic in there so you can return from main. In a lot of embedded systems applications this isn't necessary, so you could cut this out. So what we're going to do is we're going to just go through and right click, and we're going to we're just going to build the project, make sure everything's all built. Alright, after the project is built, you can see that the .elf or elf file has shown up. This is the file that's used to actually program the processor. So now that we have both our hardware and our software compiled and ready, we can start programming. So first, you program the hardware. You can open up, here's our programmer icon. It's auto detect, and we are running, as you can see from my little sticky note, the DA. So you just hit that, and it shows up. We're gonna add a file. We're gonna go into our Nios II demo output files and do the .sof. This you can delete. And on the .sof, you have to make sure that program configure is checked. And we'll hit start to program the device. Once the device has been programmed, as you can see, 100% successful, you're ready to put the Nios II on there and program the Nios II. So what we'll do is we'll right click that .elf file, and you can do run as Nios II hardware. Since this is the first time in our project we're running, it'll come up with this, and you can see that our elf file is selected in here. We want to pull up this target connection and refresh connections, and after a little bit you'll see that the our Nios processor on our FPGA will pop up over the USB blaster. Before, I've had to select this ignore mismatch system ID and system time set. You could leave them checked and see if they cause errors or not. So this will come up the first time you run your project. After the first time, it'll just save all these default settings and you can run it. So apply and run, and you can see here it says hello from Nios II. So we have successfully implemented the Nios II onto our FPGA and printed to the console using our JTAG debug module. From here you can create more advanced programs and use the switches and LEDs that we instantiated using QSys.